Okay, so I'm going to start you off with a little video clip. Make sure you pull out your notebooks. You're going to take notes really quick by yourself on this, and then we'll work together with partners. Okay?
Knight to Queen's Bishop 5.
Oh, very nice. What's Leonard going to do? Does he give up the pawn or does he give up the position?
Let's find out. Leonard, ready?
Ready. Go.
Alright, so you guys have probably all seen the movies and other television shows that have laser tripwires in them. So I want you to take about 30 seconds to a minute and write down how you think those laser tripwires work. Think scientifically too. I want you to come up with a good reasoning for why it works. Whenever you're done writing, start talking with one of your partners and try to compare what you've come up with and see if you can come up with a good answer. In about a minute, we're going to break into a bigger group and we're going to talk about this. Alright, seems like it's getting a little bit quieter now. Does anybody have any good ideas for how this works? What's the general setup, do you think, first off? Anybody? Eric?
You have a receiver, receiving port.
Okay. Got some kind of receiver here. Maybe a detector, right?
Yeah.
And what else?
That reads the light coming from
So some kind of source.
yes.
And then you've got light coming through. And it's hitting this detector. So how does that detector know that it's that light hitting the source? How does it not know if I walk up to a flashlight and I shine it on it? Wouldn't that work? If it's just detecting light, right? If I got something that's putting out light, how does it know that it's that specific light? Anybody have any idea?
Is it the specific energy level coming from those electrons?
There we go. Energy. So, what can energy maybe do to that detector? How does it know? I mean, does each light have a specific energy? Yeah. How do you know each light has a specific energy? Colors. So, what do we know about different colors of light? They have different what? Eric? No. Wavelength. There we go. So, different wavelength changes the energy. Okay, so what can energy do to the surface of this detector? Yeah.
Excited.
Excited. That's a good idea. So, what happens whenever a surface gets excited? What happens whenever you excite something? Different energy level, or maybe
The molecules start moving faster.
molecules start moving faster. So how about, you know how you can excite an energy level for an electron. Could you maybe excite it so much that that electron just shoots off? And then maybe there's some kind of system here that tells it that the electrons are hitting it. And when those electrons stop hitting it, ding, 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 alarm goes off. This system works on the photoelectric effect, which is what we're going to talk about today. That energy shot at metal can cause electrons to shoot off the atoms of that metal. The energy would be in the form of light. So, but it has to have a minimum frequency, which is related to wavelength or energy, to shoot that light off.